All right, in this second section of our first unit, we're going to be talking about increasing and decreasing intervals. So to start off with a couple of definitions, an increasing interval is any interval where as the x values increase, meaning that you're looking at the graph from left to right, the y values also increase. A decreasing interval, very similar, is any interval where as the x values increase, so again, still reading the graph from left to right, the y values also decrease. One important thing to make sure you do when you are looking at your intervals is that we only ever use the x values. So when you are listing off intervals, only the x values get used. We're not going to say anything about the y values. Now, if we have multiple intervals of increasing or decreasing, we're going to use a symbol called U to mean in union with anytime we use interval notation, which we're going to be doing both interval notation as well as inequalities like we saw with domain and range in the first section. Okay, so let's take a look at an example. For this first example, on number 1, we've got this kind of W-shaped graph. And we're going to look for which parts of the graph are increasing, meaning which parts of the graph are going up. And we've got one part right here and a second part kind of right over here. So we're going to have two kind of pieces where our graph is increasing. The first piece of our increasing graph goes from an x value of negative 1.225 to an x value of 0. So negative 1.225 less than x less than 0. The second piece is from 1.225 all the way out to an x value of infinity. So that would be the second part would be 1.225 less than x less than infinity. Another way of saying that using interval notation would be negative 1.225 comma 0, a u meaning in union with, and then 1.225 comma infinity. So two different ways of writing the same thing. Preference might be towards one or the other. I would say interval notation is a little bit shorter to write though. All right, let's talk about decreasing now. So where our graph is going down. So we've got this first section of our graph as well as this kind of third section of our graph, which are both decreasing. That first decreasing interval actually starts at an x value of negative infinity and then continues to decrease up until that x value of negative 1.225. So we would say negative infinity less than x less than negative 1.225 for the first interval. And then the second interval starts at 0 and goes to positive 1.225. So that would be that 0 less than x less than 1.225. Again, with interval notation, you would just use parentheses to say negative infinity to negative 1.225 and union with 0 to 1.225. Okay, let's take a look at another example. So a little bit less going on in this example would be a good one for you to try on your own if you wanted to practice one and pause the video. Let's talk about the increasing intervals. And there are two increasing intervals. You are increasing on this first interval and then also increasing on this third interval. So the first interval starts you at negative infinity and takes you to an x value of 0. So negative infinity less than x less than 0. The second takes you from a positive 2 out to a positive infinity for your x value. So 2 less than x less than infinity. Again, if you wanted to use interval notation, negative infinity to 0 in union with 2 to infinity. For decreasing interval, we've only got one of those, and that interval takes you from an x value of 0 to an x value of 2. So we would say 0 less than x less than 2, and that would be in parentheses from 0 to 2 if you wanted to use interval notation. All right, one more graph to look at here. So this third graph, we've got one increasing interval, which is going to be this first interval. We've got one decreasing interval, which is this third interval. But we also have a third interval in the middle, and we'll talk about that in just a little bit. Let's first just talk about the increasing and decreasing intervals. So the increasing interval starts at negative infinity and goes up to the x value, which the x value there is negative 1. So we would say negative infinity less than x less than 1, or we could say negative infinity up to negative 1. Let me make sure I get the negative back over here. Okay, so there's our increasing interval. For decreasing, we're going to look over here on the right side of our graph, starting at positive 1, and then going out to an x value of infinity. So 1 less than x less than infinity, or 1 comma infinity in parentheses for interval notation. Now, as far as what did we notice in example 3, there's one interval that we didn't talk about. So when a function is neither increasing nor decreasing for a set of values, we're going to say that the function is constant. In other words, we would say that the function was constant from negative 1 up to positive 1. Another thing that we might have noticed is that there are some points where the graph switches from increasing to decreasing or vice versa. So we're going to have a couple of special names for those points. The first is going to be what's called a local maximum. So a local maximum is the point where a function switches from increasing to decreasing. So it switches from increasing to decreasing. So a local maximum looks like the top of a hill. A local minimum is going to be the opposite. So a local minimum will be any point that switches from decreasing to increasing. So it's going to look like the bottom of the hill. So we're going to look at a couple examples. In fact, I think just one example here of finding some of that key information. We're going to put some stuff together. The first is we're going to look to see, does it have any local maximums or any local minimums? Now there's only one point that I can see on this graph that could be one of those two things, which is at 1, negative 3. And to me, comparing to these two pieces right here, it looks a lot more like the second one. It looks a lot more like a local minimum, meaning the graph has switched from decreasing to increasing. So our local min would be that point 1, negative 3. Taking a look at the graph, notice that there really aren't any points where the graph switches from increasing to decreasing. In fact, it's only increasing on this right side of the graph, and it never starts decreasing. We never see a point where it starts to turn. So in this case, we're actually going to say that there are no local maximums. Okay, talking about the domain of our graph. If you look at our graph, we're going to the left forever. We're also going up and to the right forever. So our domain would be from negative infinity up to positive infinity. For the range, we're going to look at our lowest point, which we actually do have a lowest point. Our lowest y value is at negative 3. Our highest y value, our graph goes up forever towards positive infinity. So our range would be negative 3 to infinity. I've written domain and range in interval notation. If you wanted to use inequality notation, you could do that as well. Same for increasing and decreasing. I'm going to write those using interval notation. So for increasing, we've got kind of this right half of our graph is increasing. That starts at an x value of 1 and continues to positive infinity. For decreasing, that's our left side of the graph. Remember that you're still going to go from left to right. So that would be from negative infinity up to 1. And there we have it. All right, that is it for this video's lesson. In the next lesson, we'll talk a little bit more about some critical points. Until then, have a great day.